So collinear points. What are collinear points? Is the mathematical question in discussion of this topic. So what are collinear points? Collinear is the word which is used for the points identified on a line. Linear is the word extracted from this, that means straight line. So collinearity is related with a straight line. So what are collinear points? I say points A, B, C are collinear. These three are said to be collinear if they lie on same line. That is, if I take the line L, which has all the 3 points A, B and C, then I say that these 3 points are collinear. If I have any other point D which is outside of, then A, B, C are collinear, but A, B, C, D are not collinear because this is outside of the line. For the points to be collinear, I need to have all the points on a fixed straight line. Therefore, for the points A, B, C to be collinear, all 3 must lie on same line. This is how we understand the collinearity. So how do we solve problems where we have to justify whether the given points are collinear or not? So let's connect collinearity with distance, which says that mathematically A, B, C are collinear if I see the straight line AB plus BC is AC, then I say the 3 points are collinear, because if I add AB and BC indirectly, I get AC. So when I connect this with the distance, ABC are collinear if AB plus BC equals AC is an important formula I take in solving problems related to collinearity. So when I want to show that the 3 points are collinear, I find AB plus BC and I find AC. If these 2 quantities are equal, then I can say the 3 points are collinear. So let's follow this concept through an example problem and see how we can prove for 3 points to be collinear. So let's take a practice problem to identify the collinear points. The question is, are the points A, which is 1, 5, and B, which is 2, 3, and C, which is -2, -1, collinear? This is the question I have. So I wanted to know if these 3 points are collinear. So we have to use the property. I have the definition for collinearity. I have the definition which says AB plus BC must be equal to AC. For collinearity, AB plus BC must be equal to AC. Therefore, let's simplify the left hand side and the right hand side and see if both are equal. So coming to the left hand side, I have AB plus BC. So initially let me calculate AB and then BC individually. So what is AB? It is the distance between 2 points where this is x1, y1 and x2, y2. Now using the distance formula, this is x2 minus x1 whole square plus y2 minus y1 whole square is what I get when I use the formula. Now this comes out to be 2 minus 1, which is 1 square, plus 3 minus 5, which is -2 whole square. So this is 1 square plus 2 square, which is 1 plus 4 root 5. So this comes out to be root 5 clearly when I add each of the terms. Similarly, let me find BC, which is the distance between the points B and C. where this is x1, y1 and this is x2, y2. So root of x2 minus x1 whole square plus y2 minus y1 whole square, which on simplification gives me minus 2, which is minus 4 whole square plus minus 1, minus 3, which is also equally minus 4 whole square, which gives me 16 plus 16, which is root 32. On simplification, this is nothing but 16 2's 4 root 2. So I get this to be 4 root 2 and this to be root 5. Then finally, let me also find that implies my AB plus BC is root 5 plus 4 root 2. So this is what I get on the left hand side. Similarly, let me calculate the right hand side, which is AC, and see what I get out here. So let's take the right hand side. My right hand side, which is AC, is calculated by taking this as x1, y1 and this as x2, y2 between A and C. Therefore, using the distance formula, I get here root of x2 minus x1 whole square plus y2 minus y1 whole square is what I get in simplification. And then minus 3 whole square plus minus 6 whole square, which on simplification gives 9 plus 36, which is 49, or root 9 plus 36, 40. This comes out to be 3 root 5 is what I get for AC. But clearly I can see that AC is 3 root 5 and AB plus BC is root 5 plus 4 root 2. They are not equal. So from 1 and 2, I can say that AB plus BC is not equal to AC. Hence, ABC are not collinear. That implies ABC are non-collinear. That is, the 3 points do not lie on a same straight line. If the left hand side was equal to the right hand side, then I could have said that the points are collinear. But since the left hand side is not equal to the right hand side, the points are non-collinear, is how we justify the given points for collinearity or non-collinearity.